Simplify 1 over x minus 1 over y all over y over x minus x over y. This is more complicated than the first examples we did because the numerator and denominator both have multiple terms. There are subtractions in the numerator and the denominator. When there are additions or subtractions in the numerator and denominator, things are more complicated because our problem is no longer a single fraction divided by another fraction. We've got something much more complicated here, and so we cannot use division in the same way that we did before. The method that we used before I usually refer to as the division method, but here we need a new method to deal with this, and I call this the LCD method. Basically what we want to do is we want to get rid of the fractions in the numerator and denominator, and so what we need to do is we're going to multiply the top and bottom by the same thing, and the hope is to get rid of all of those denominators. We've done something like this before when we solved equations with fractions in them. We wanted to multiply the left and right hand sides of an equation by the LCD to get rid of fractions. And here we want to multiply the top and bottom of the main fraction by the LCD to get rid of the fractions. So the first step here is going to be to find the LCD among all of the smaller fractions. So we need to find one LCD that works for the fractions in the numerator and the fractions in the denominator. And then once we find that, we are going to multiply the top and bottom of the main fraction by the LCD. And then after we do that, all of the smaller fractions should be gone, but we might still need to simplify. There might be more things that can be reduced. So at the very end, we are going to simplify if possible. Let's use these steps on this problem so that we can see how it works. I'm actually going to rewrite it a little bit bigger and a little bit further away from what's already written so that we have some more space. So this is the problem. Now if we look at all of the smaller fractions, the denominators are x, y, x, and y, and the LCD among all of those is just going to be xy. We know the LCD has to have an x as a factor and also a y, and so the LCD here just becomes xy. And so what we're going to do is we're going to multiply the top and the bottom of the main fraction by the LCD, in this case xy. We know that we're allowed to multiply the top and bottom of a fraction by the same quantity, and in this case that is exactly what we're doing. And to accomplish this, we're going to have to distribute the xy into all of the different fractions. So all of those small fractions are going to get multiplied by that LCD. Let's take a look at these one at a time. Let's look at what happens when this xy in the top is multiplied by 1 over x. Notice that we're going to have some cancellation. There's an x in the denominator, and there's an x out front. This xy is technically xy over 1, so you can think of this x as in the numerator. So the x's end up canceling, and what we're left with is the y times 1, which just gives us y. I don't want to physically cross out the x here, because that only cancels in the first term. In the second term, the x doesn't cancel. It stays there, so it would be confusing to actually cross that out. So when we're doing canceling, we just need to think about in our heads what gets canceled. Now, for the second fraction, we have a subtraction, so it's still going to be subtraction. And then we have xy times 1 over y. In this product, the y's are going to cancel because we have a y in the denominator and a y out front, and that leaves us with the x times 1, which is 1x, or just x. So we are left with y minus x in the numerator when we multiply by the LCD. And this is good because we don't have any fractions in the numerator anymore. That's really our goal, to get rid of those smaller fractions. Let's look at the denominator now. We will distribute the xy into the first fraction. And here you'll notice that the x's cancel. We've got an x in the bottom and an x out front. Those are going to go away. And what's left is y times the other y. And y times y is y squared. So we've got a y squared there. Then minus, because there's a subtraction, we have to distribute the xy to the second fraction. And here it's the y's that are going to cancel, because we've got a y in the bottom and a y out front. That leaves us with x times x, which gives us x squared. So we've gotten rid of all of the smaller fractions, and we're left with just a regular rational expression. But this actually can be reduced. Remember, when we are simplifying rational expressions, we need to factor any polynomials that are factorable, and that denominator is a difference of two squares. Y squared minus x squared is y plus x times y minus x. And at this point, we notice that there is a factor of y minus x in the top and bottom that can be canceled. Now, what's left in the top? Well, y minus x is technically 1 times y minus x, so we're left with that 1 in the numerator, and in the denominator we have the y plus x, and now everything is simplified, so we have our final answer, 1 over y plus x.